Good. My presentation is done. Now, what I want to be able to understand from you is, what do you think, when you think about cloud and what do you think about security, what do you really mean when you think about cloud? Can anybody say, what do you, from your own perspective, what do you think is cloud for you? Go ahead.
It's a multiplexing of the physical resources that can, so you can use virtual part of that and be charged by only the part you use.
Yeah, so it's pay as you go, right? And pay only for what you use. So it's renting versus buying, isn't it? In some sense.
Yep.
What else? Another way of defining what cloud is.
In that sense, it's kind of shared service. You share the computation power, you share the storage with other tenants.
Is it like a bus or a taxi?
Bus.
It can be a taxi also, right?
It's actually a combination.
Yeah. So it can be multiple situations. It depends on what you want. If it's a shared host versus a dedicated host, you can get a taxi or a limousine or a truck, whatever you want. Essentially, it's what you define as what you need in terms of resources, right? So now let us talk about security. What do you mean by security? And what do you want to secure? When you want to keep something safe from somebody, who is that somebody? And what do you call them? I call them adversary, right? The bad guy. Maybe a girl, I don't know. But why do you have to be a guy? But forget about that. So there's an adversary, and you want to protect. What do you protect from them? Money is one. What else do you want to protect? So money, data. Can I use a generic term? Sorry? Reputation. So I just call it my assets on the balance sheet, right? That's what I want to really protect. And I want to grow it. I want to keep it safe from the adversary, right? So how do you actually do that in real life? Forget the cloud for now. How do you do it? How do you protect your asset? You hide them. How do you encrypt an object like this pen? You don't, right? I'm talking physical world, real world. How do you encrypt a pen? You don't. You hide it. You keep it safe under lock and key. You put a police guard there, things like that, right? Or you don't expose it. So similar concepts when you apply to cloud computing are applicable. And I'll now give you an example. This concept is called just enough OS. Have you heard about this thing? It's called JUICE. You know what that would mean in context of, say, a Linux machine? What would JUICE mean? Just bare minimum operating system that will run enough to run OpenSSH and nothing else. So I can connect to it. No other services, nothing else, just enough operating system to boot something up. Probably Google has more than just enough OS. I'm assuming maybe you have a bare minimum OS available. If you go to ubuntu.com, you will find a mini.iso. Have you seen that thing? It's like 32 MB file. It's an ISO file. You load it up. All it does is boots up your machine and does nothing else. That's the bare minimum OS. The physical equivalent of that thing is to hide whatever else you have from the adversary. You don't want to expose unnecessary services, unnecessary applications. You don't even want to run and install them. You don't even have them because that increases exposure. And so attacker can attack you, right? That's the concept of when I boot up a machine in cloud, what I would do is actually take the bare minimum OS and very carefully add exactly what I want to add to that machine to build up my cloud, machine by machine. That's one way to think about security, and this is my approach. What do you think? Have you heard about this kind of thing before, or is it new?
The problem is, in real life, we actually do the opposite. We install antivirus, all the security software.
Yeah, you need antivirus. Sometimes you do, right? But in certain operating systems, you don't even have them. There is no such thing available. And so antivirus is useful for desktop operating systems like you have this Macintosh here or Windows machines. Or sometimes there's an antivirus for Linux also. Some flavors of that are available.
But there is a television commercial out there that says you can't steal it if you can't find it. I can't remember what company it's from.
So that principle, yeah. Yeah. So that principle is called, yeah, it's called security through obscurity. And that principle is not really secure because what if you find it? Then you might steal it, right? Yeah. So you want to be absolute security if you really want. You want to make sure that nobody can actually catch it. So in the context of a server, the commonly used method is called firewall, some antivirus, intrusion detection, using no passwords, locking down access to only my home, my office, my IP address, my cell phone, and only from these points I can access my machines in the cloud. That may be a method. There are other methods that you might have heard of called using a public key, private key combination. Are you familiar with that? Who has not seen a key generation method, and how do you actually do that? If you want to see it, I can quickly show it to you if you have it. Show it. Okay, good. So what you see now is a terminal, right? Are you familiar with this thing called terminal? It is an application that runs on the OS, and what you do is SSH key gen, and then you define a particular protocol, give it a label, call it lwtech.edu, and enter. It'll ask you some questions like a passphrase. Give me a pass, or where do you want to save it? So I want to save it locally in the name I want to give is Nilesh, and no passphrase, and keep going. So it created something called Nilesh in the current directory. So if you make it a little smaller so people can see, there are these files called Nilesh, and nilesh.pub got created, right? So the file without an extension is the private key. The file with an extension is the public key. Now, can anybody give an example, a real-life physical example of this thing? Like, what do we do? Huh? Right, it's an implementation in the virtual world, in the computer world. I'm talking about physical world, objects. Where do you see this thing in real life? Forget computers. It's called lock and key. You have a lock and you have a key. You use the key to open the lock. The same concept is here.
Different in
Yeah,
sense you can give
concept.
a public key to anyone.
Yeah. You can give the public key is the lock.
Public give your key to everyone.
Yes. The concept is, the idea is you have, let's open these files and see what goes on inside there. So I'm going to say, I'm going to open these two files. So what you see here is the public key. Is it? Yes, it is the public key, and here's the private key. Encrypted long numbers based on some algorithm that I use was DSA. And this, what you see right now, is the private key that only I need to know. Nobody else on the planet Earth will have it. This is the actual key in the context of physical objects. The pub file that you saw earlier, which is here, is the equivalent of a lock. So this is what you put on the cloud servers. And you put it in a specific location called authorized hosts file inside the home folder for that particular account. And you can read more about that. So that's the idea. When you do this, you want to make sure that these keys, the private key essentially, is stored very safe with read permissions only for you, nobody else. You don't share them like you don't share underwear. You never do that. You absolutely keep them private. And you rotate them, meaning you take a shower every day and you change the underwear. That's the idea. So you don't want to share private keys. You keep them secure unless you're Sony PlayStation. Then you lose your all private keys and give it to everybody else. That has happened, by the way. It's on record. You can see on Wikipedia. So this is a method that we have been using up until now, until this thing called Heartbleed came out. Have you heard about Heartbleed?
Oh, yeah.
So who knows about Heartbleed already? So I don't need to go into detail. 1, 2, 3. Who wants to see how Heartbleed actually exploit works, and how does the Canadian hacker?
Let's see it.
Good. Yes. I will say that please do not use this exploit, but I will demonstrate. Yeah. So let me give you a concept here first. So Heartbleed essentially is, yeah, go ahead. So Heartbleed is a bug. It's a vulnerability found in a protocol that is called OpenSSL. Actually, the protocol is called SSL. OpenSSL is an implementation of that protocol. The newer protocol is called TLS, Transport Layer Security. So you connect to Google services through IMAP protocol. They will ask you to say start TLS, enable port number 587. That's the protocol. You remember that setting in Gmail somewhere? So now in this TLS protocol, there is another implementation called heartbeat, not bleed, beat. The reason they have this concept of heartbeat is to maintain and open up a TLS transaction, this TLS, transport layer security that I talked about, this transaction to establish a session with, say, Gmail, takes some time. And it may be few seconds or maybe less than a second, but still long in the computer in a computer time sequence. We don't have too much time to spend and waste away. So we maintain a method called heartbeat. So you want to make sure that the other guy is active, alive, and kicking. And I know him or her, and I'm able to see the heartbeat. That's the method of understanding if the other machine is connected to me and I can go back there and connect to it. So in that heartbeat, how does it actually work out? And that's the vulnerability inside OpenSSL implementation 1.0.1 all the way through version A through F. All these versions from A through F, they have this vulnerability even today unless you update that thing. So the heartbeat method essentially is, so if I know that guy, Dan, and I'm talking to him, hey, Dan. So I establish, so he says hi. So I have a connection with him now because I identified him. I looked at him. He looks like Dan. I checked my ID and compared with him. He looked like Dan. Yes, he is Dan. OK, good. Dan, are you there? Yes. Yes. So I have a connection established now. And I'll again go check. Hey, Dan. Dan says hi. That's the handshake. It is known as the heartbeat. Now, the actual implementation of heartbeat happens something like this, that the other guy could be an attacker. The deliberate attempt of attack goes like this. The other guy, the attacker, will send a byte and also send the information that I am sending you 1 byte. So this guy is probably not an attacker. He's not lying, right? He's actually sending a byte and saying that I'm sending 1 byte. He's not lying, not cheating. Now, what the attacker would do is send 64, say that he's sending 64 kilobytes. So that is 65536 number of bytes. He'll say the size is this much, but actually send only 1 byte. He lies or she lies and cheats. So the other guy, the server, thinks that, we just received a request of size 64K. And so in the response to heartbeat, the server, the other end, the buggy OpenSSL, vulnerable server responds back with, so let's draw a map here. So on the server side, that is the machine that is vulnerable. You have a memory map. The guy sending only 1 byte, but claims that he sent 64K bytes. In response to the handshake, the heartbeat, the guy returns 64K bit of memory. Instead of sending only 1 byte back, this thing sends 65535 extra bytes back to the attacker. And this way, the attacker is able to read memory map in the other process. And you can just repeatedly keep attacking and keep reading random areas of memory. And in that memory, what contains in that memory is the key I talked about. You saw me showing the key, the private key, and the public key, whatever the transaction is happening. The attacker can grab memory, chunks of memory, 65535. These chunks, every time it sends a heartbeat signal, give me some 64K minus 1 byte of data, and I'll store that, collate that, and read through by hand and figure out what segment may be the private key. And now I have unfettered access to that machine. That is the thing which was a bug, which was now fixed in OpenSSL 1.0.1G. And so if you are running this version, that's good. If you're not running this version, update it right now. Right? So that's the concept of heartbleed, and it has been, the patch is available immediately. In fact, I can show you that. Here it is. So you see that terminal again? Let's see, in Macintosh, they don't have the bug because the version is 0.9. So we'll say on the terminal, say open SSL version -A, and see what it says, 0.9. This is not vulnerable. It's version 1.01 A, B, C, D, E, F. Those are vulnerable. This one is not. Let us connect to a Linux machine. Oh, sorry, not this. Cancel. So I'll connect to a remote computer, which is a Linux box, and I'll show you how to identify a vulnerable version versus a non-vulnerable version in a remote computer I'm connecting to. I think it connected. Yes, no, it's not yet. Why is it slow? But if it's not connecting, I cannot do anything except tell you that you look at the build on date. You run the same command, look at the build on date. If it is April 2014, you're good. If it is not, you have a problem. Run. So that's how you look at it. I don't know why it's not connecting to my remote machine, but I am going to ignore that, break it. So what else you want to hear about cloud computing security is what my question is. Go ahead.
Well, I don't want to throw a monkey wrench into your
Please do. I invite that. Go ahead.
There's actually no way to secure an open operating system smartphone or tablet. There's just no way. The only way to stop hackers and illegitimate people from trying to steal information from you, and by the way, they're mostly concerned about your credit card details. They really don't care how many girlfriends you have. They're mostly concerned about stealing things that they can get tangible results from, an ROI. And what they're concerned about, and what they do is they put malicious code inside of legitimate applications. Those legitimate applications then go onto the cloud, and it's like a fox in the henhouse.
So you're basically saying that somebody is deliberately selling you a finished product which contains malicious code to begin with? Or is it an after the fact? Don't buy such things. Don't buy such things. Don't buy such things. I mean, don't, even if it is free, you're still buying.
The problem is you're a very smart security person, which I respect, but the problem is the whole world buys smartphones and tablets, and they go to third-party app stores, and they can't justify the validity of those app stores, and there it lies the problem.
Yep, it is a problem, I agree, and my advice to everybody is, if the price is free, you are the product.
But there is a way to solve this. There's something called the Trusted Computing Group, and the Trusted Computing Group, I hope one day, maintains that they create a trusted computing site where applications can be trusted to be downloaded. But until that happens, quite honestly, you're all software engineers. I'm not, but I have advanced knowledge about mobile security. And I say that there should be a consortium put together to create trusted computing apps, and then have a combination of software and hardware security for tamper resistance, because it does exist with one particular kind of technology, but the world doesn't really know about it yet. It's called the TEE, the Trusted Execution Environment. Are you familiar with
Yes,
that?
yes, yes.
So am I.
There are lots of
I'm
things.
not an engineer, and you guys are. I'm not. Thank goodness I bring to this discussion a down-to-earth situation here, which exists, which is we have no security in our mobile devices, but we will when more people get professionals like yourself evangelize the problem, which is, I'm telling you, quite honestly, people don't know that their mobile devices don't have security, and few people are willing to tell the truth about the big problem. I believe you're a man who will tell the truth and explain to the people they have no security on their mobile devices. That's why the NSA can get into hack it, and that's why the other countries around the world can hack. So I'm sorry, it's a big, the topic is broader than what you're trying to suggest.
Yeah.
It's really broader.
It's a societal problem. though.
So, you know,
People want convenience.
this problem exists in real life also. You go to
Yes,
India.
that's what I'm talking
Go to India, you will have this problem right there on the
Yep.
street. What do you do there? What would you do there?
Well, ARM and Intel are doing something about it, actually.
Yeah, forget computer science. Think about physical security. There's a police officer there. Hi. Come on in. We're talking about physical security, so come on in. The idea is, you know, if you go to developing countries, these problems exist every day.
Yes.
You know, I have been a victim of such problems. You know, I know how to deal with in developing countries. When I go back home in India, I know how to operate there. But, you know, if you're showing up there and in the wrong places, it'll be trouble. It's a fact of life. Just understand that and live it.
Well, I understand mobile devices, and I understand that Intel and ARM know that there's no security, the thing I just talked about, and that's why they're trying to create a firewall in the chip, which is more tamper-resistant.
Yeah. So there are things like TPM is coming up, you know, in machines like Windows PCs will have it, a trusted platform module. It's a hardware chip inbuilt.
I had an occurrence recently where somebody came to me and said, a customer came and said, my CEO doesn't want the passcode on his device and your mobile solution enforces one. Take it off.
Yeah, you can take it off, but it's a bad thing to do. But if you understand, it's a risk assessment. How much risk you want to take? What's, if you look at my phone, I actually use a passcode that is 1111 because it is easy. That's what I do. And so I don't care because I know that I'm going to provide physical security to the device, and also I will not be stupid to download silly apps. And Apple will do a great job in this context because what they have is a walled garden, right? You know what a walled garden concept is?
Yes.
And so you prepare a wall around your beautiful garden, and if you're playing inside it, it's great. But it is not freedom. So if you want freedom, you go somewhere else, like Ubuntu. No, it used to be free. It's not free anymore. There is a cost to it. The cost is freedom. It's Libre. It's not Libre anymore. It used to be open source. They controlled it. He can correct me if I'm wrong. But there are certain aspects of Google code, Google Play code, that you cannot get unless you sign a contract with them.
Right. But actually, Google Play is using the TEE, and he should know that.
Sure. So any other questions? Anybody else? You want to talk on specific things, or are we done? Bring any topic in security. Bring it on. Quiet. So let me say one more thing.
Sort of related to security, privacy. Privacy, security sort of go hand in hand.
Yes, it does. Yes, it does. In broad context, that's what privacy is. One aspect you want to keep secure. You don't want to go, expose yourself inappropriately, in some sense, inadvertently, inappropriately, in some sense, right? So in summary, we have a class starting here in Lake Washington. Yes. May 13th is the last date of sign up. And also we have another session talking about cloud computing and how can an organization like Revenue Canada can patch their machines so that a 16-year-old teenager cannot steal social insurance numbers in 2 minutes. We talk about these things. There's a seminar series happening in Lake Washington Institute that I talk, and May 13th is a session that we'll talk more specifically how to patch your entire cloud infrastructure, thousands and thousands of servers like Google claims. You can have your own cloud like this on their property. For how much do you charge? Like 2 cents, something like that? They're giving away free. Take it, literally. People like Amazon, Google, Microsoft, they're fighting in a downward trending price war. Make use of it. It's the opportunity right now. So hear more about it May 13th, 6 p.m., Redmond campus. And this class registration is open. Closes May 19th, class starts. A 3-month course, talks about technology, architecture, and DevOps, operations, and I teach that course.
What's the cost for that class?
4,000, total 3 months.
US.
Yes. It's not an Indian class. It's not in rupees.